This video shows you how to install anti-tips to prevent your furniture or wardrobe from tipping over. The first method involves installing metal mount brackets with steel wire straps. So here are some of the tools that you will need to get the job done. You will need your tool kit, which encompasses your drill bits. You need your drill to drill the hole and drive the screws in. You've also got your measuring tape and your metal mount brackets, as well as your steel wire straps on the table, and also your great plugs which secure the screws in the wall. The metal mount and the screws are of two sizes. The metal mount and screws that go into the wall are larger than the metal mount and screws that go onto the furniture. Latch or match your screw thread profile against the drill bit that you'd be drilling the wall with. Ensure that the profile of your drill bit is slightly smaller than the profile of your screw. And that's because we know that the screw fits in perfectly into the grey plug, so we're not going to be drilling an oversized hole if we choose a drill bit that's slightly smaller than the threading profile of our screw. And if we drill an undersized hole, we have nothing to worry about. We just open up the hole to the final size that we want. And I have also taken cognizance of the length of the screw as well as the length of the plug. I will be masking the drill bit, on the full length of the screw or plug, so that when I drill, I don't drill too further into the wall, okay? Or overly deep into the wall. So I will replicate or repeat and reproduce the process for them smaller screws with respect to how I have selected the drill bits. And so you can see here that I've taken cognizance of the length of the smaller screw. I will be masking the drill bit, around the full length of the smaller screw, so I do not drill too further into the wood or the wall, okay? And you can see here that the masking of them two drill bits has been sorted. Here, we will be utilizing the Franklin Sensor 710 Pro. The Franklin Sensor is a stud finder. And why is it important that we have a stud finder? The reason why it's important that you have a stud finder is that you do not want to be drilling blindly into your walls, because you could catch on to a live cable. You could also catch on to metal pipes, metal plates that are covering live wiring, as well as, water pipes in the wall, which can be very costly to sort out the cosmetic repairs. Is the Franklin's sensor a very good device? I will say it's a good device, but like with every device, it's got its limitations. No system is foolproof. So the Franklin sensor has an advantage in that it can detect wooden studs, okay? It can detect dense materials, but it cannot identify live cables or metal pipes, so you'd need a different type of detector to detect, metal pipes or live cables, or metal plates that's covering live wiring, okay? So here I will insert both batteries with respect to their polarities so that I can activate the sensor. The Franklin sensor has also got a spirit level, so if you're not level on the wall, you can tell by the inclination of the spirit level. The spirit level is on the midsection of the battery cover, with its liquid content flowing in the glass tube. And so to look for wall wooden studs, you press down the yellow button on the Franklin's sensor prior to placing it on the wall to get more accurate results. And when you come across a wooden stud or a dense material, the LED light illuminates red, okay? Once you've worked out where you should be drilling, you're about 3/4 of the job done. So preparation or prepping is very important for every job, okay? Ideally, you shouldn't drill 150mm from corners, okay? So I wouldn't be drilling 150mm from the roof or from the blind, the corner of the blind, okay? So first, I will be working out the height at which I want to install the metal mount brackets, whilst making sure that the furniture height doesn't fall within the 150mm electrical wiring zone. The next step would be to work out the exact location where the metal mount bracket will be fitted. It must be tantamount to the other location where the metal mount bracket will be fitted on the wardrobe. The steel wire straps will run through two holes on the larger mount bracket which fits onto the wall, and the other two holes on the smaller mount bracket that fits onto the wardrobe. Whereas two screws each will be fitted or screwed onto the larger mount bracket that fits onto the wall and the smaller mount bracket that fits onto the wardrobe. And so the big question is, where do we drill to fit the larger mount bracket on the wall? And that is where your stud finder becomes useful. Wooden studs are usually hidden behind your wall, and studs are 16 inches or 24 inches center to center apart. Suffice to say, studs can be spaced 16 inches from center to center behind your wall or 24 inches from center to center behind your walls, okay? Studs generally coming in 2x4s, and if you chamfer off half an inch on all four sides to make it more refined, it's 1.5 inch by 3.5 inches. And so you could say studs coming in 1.5 inch by 3.5 inches, where 1.5 inches is the depth or the thickness, and that is what we're concerned with, because that is where we will be driving our screws through the metal mount brackets in. And so, if the depth or thickness of the wooden stud is 1.5 inches, that should be replicated on the Franklin's sensor. So 3 dotted LED red lights on the Franklin's LED sensor should illuminate, which will connote that we found the wooden stud behind the wall. And we're also not looking at drilling at 90 degrees or perpendicular path straight lines from sockets or switches, as well as 150 millimeters from corners, okay? And for mounting the smaller metal mount onto the wardrobe, drill with a drill bit whose profile is slightly smaller than the threading profile of your small screw. You can also mask the threading length, on the drill bit so that you do not go far too deep into the wood. So here I will be marking off any 3 LED red points that illuminates on the sensor, and we'll be drilling on the center or the middle of them 3 points or lines that have been marked on the wall. Anytime you move the sensor to the left or to the right, the 3 red LED points moves to identify the static position of the wooden stud. It tells you that this wooden stud is there, and that's why it moves alongside with the movement of the sensor. So I have set the drill setting to manual drill, varied the speed to 2, which indicates drilling. I have also pushed the knob down to indicate that the force of the drill bit would be going in the downwards direction as opposed to removing the drill bit from the wood or the wall. It's pretty much up to you, but if you can gauge how you drill, with eye inspection or with visual inspection, that's also fine, okay? Then subsequently drill the second marked hole of the metal mount. Also remember to press the knob in the upwards direction when you're getting the drill bit out of the wood, otherwise you might snap your drill bit. And now that we've drilled the holes with a slightly smaller drill bit in relation to the screw's diameter, and then we vary the speed of the drill to 1 and screw down the screws into the metal mount, and we can be sure that we'll get a tight fit, of the screws because we used a slightly smaller drill bit to open up the hole. So once we're done, securing the metal mount onto the wardrobe, we're going to replicate the same process on various positions or locations on the wardrobe and the wall, so that the steel wire straps exert a coherent counterforce in relation to the wardrobe's applied force per unit area. Suffice to say, we want the anti-tips to be able to withstand the stress and the strain emanating from the wardrobe's load. The more sturdy anti-tips, the better. And so the next step of the process would be to drill out the marked out holes from the larger metal mount. Again, you can make sure that you don't drill too deep by masking out, your drill bit, or you can just drill by visual inspection. But I've chosen to mask, the drill bit. But something interesting happens here right before I get to the masking. I can't seem to go any further, drilling the hole. and I can hear an audible squeaky sound, so that tells me I may have just met, a metal plate. And this is a classic example of a drill bit clashing with a metal plate that covers live wiring running through your wooden stud. And so, although we've located a stud, it's got, a metal plate covering on it, so it shouldn't have been drilled in the first place. And if we drill the other hole where the mounting metal bracket goes onto, we're still going to clash with a metal plate, which can be quite dangerous, okay? If the metal plate covering wasn't there, we may have clashed with the live wire, and that may have been very catastrophic, as it may have resulted in electrocution or a short circuit. If you want to see how to cosmetically repair the holes, click on the link in the description, okay? And if we visually inspect the hole, we might just be able to see the metal plate covering on the wooden stud. And so it doesn't matter where you drill, above the center hole or below the center hole, you will still clash with the metal plate covering. And if I zoom out and close out to the center hole, you might just about see the metal plate covering over the live wires. And so I hope you can just about see the metal covering that prevents the drill bit from going any further. And so, although we have found lots of wooden studs on this side of the wall, they have got metal plates covering them, so we cannot utilize them wooden studs, okay? And so we will have to repair the wall and try to find wooden studs on the other side of the wall, okay? All this could have been avoided if we had a pipe, metal and cable detector, as the Franklin's sensor is capable of locating studs or dense material, but it isn't capable of identifying what type of material it is. And that's where your pipe, metal and cable detector comes in handy or useful, as it is capable of identifying these materials as the name implies. Click on the link in the description to see how to use the Bosch multi-level pipe, metal and cable detector. So I have switched wall sides, utilized the Franklin sensor to locate studs and dense material, and also utilized the Bosch metal detector to identify if we've got metal pipes, metal plates or live wires, and drilled, subsequent holes where I will be installing the larger metal bracket mount. So here I will be replicating the process but drilling 8 holes in 4 respective wall stud locations. And based on utilizing the Franklin's sensor and the metal pipe and cable detector, I am pretty confident that we've got 4 wooden wall studs, behind the wall. And every time I drill into the wood, you can see I'm, stopping at the masking so that I don't drill too further or too deep into the wood that sat behind the wall. And, I'm utilizing an envelope to collect all the debris so that I do not soil the carpet or the floor. Just run a tape across the envelope and you should be fine, okay? And like I said, for drilling them holes, just replicate the process as earlier highlighted. Select, your appropriate drill bit. Measure the height of both brackets against the wall and the wardrobe, okay? So both the smaller bracket and the larger bracket should be facing each other at the same height. And once fully installed, we're going to run steel wire straps through both of them. And so here, I'm looking to install 4 anti-tips. The more anti-tips, the more rigid or sturdy the wardrobe would be when load impacts on it. And so subsequently, at a later stage, I'll be pushing in the plug flush against the wall and driving in these screws using a drill to install the larger metal brackets with the knob pushed down. So how do we get 4 brackets installed at the back of the wardrobe? We can do it in 2 ways, okay? We can cut 2 holes using the hole sawer and a mandrel and install brackets just underneath the wood shelf. Or we could install 2 metal brackets, just directly behind the wood shelf. And so, if you've got a longer wire strap, you can actually get your hole sawer, cut about 2 holes here, okay, so that you can install your metal brackets just underneath the shelf. But if your wire strap is short, then you can install it directly behind the wood shelf. My wire strap is short, so I will be drilling the wood shelf from behind, okay? So that when I run the wire straps through the metal bracket, it can easily latch on or catch onto the other metal brackets on the wall. So here I have decided to install 2 brackets and 2 D-rings. The distance between the 2 holes on the metal bracket is larger than the thickness of the wood shelf, so I will be drilling just 1 hole for each D-ring and each bracket that goes behind the wardrobe. Suffice to say, 1 screw will secure each D-ring and each bracket behind the wardrobe. So here I will be drilling at the center of the wood shelf's thickness, which has been identified or located by taking measurements from the top of the wardrobe to where the wood shelf sits. So here I will drill 1 hole for each D-ring that will be installed directly behind the wood shelf, and then subsequently replicate or repeat and reproduce the process for other holes. And so here you can see the 4 holes that have been drilled. The next step would be to install the D-rings and 2 metal brackets. So 2 D-rings and 2 metal brackets will be fitted behind the wardrobe with 1 screw each. And so that's pretty much the fittings at the back of the wardrobe sorted. And so, just as discussed previously, if you've got a longer wire strap, cut open about 2 or 4 holes at the back of the wardrobe so that you can install your metal mount just underneath the shelf this way, and then subsequently get the lanyard braided strap cable into the cutter hairpin retaining clip that secures the lanyard to the metal mount, and then subsequently pass each lanyard through the hole insertions that was made by the hole saw mandrel at the back cover of the wardrobe. Pass it through all them holes so that they can catch onto the other mount metal bracket on the wall. So as previously highlighted, zooming in close, we have got our cutter hairpin clevis pin flathead pin, which slides into the metal bracket mount, and right before it slides to the other end of the bracket mount, rather than using the steel wire, I will deploy the use of the stainless steel wire rope lanyard cable tether safety braided strap. This is an alternative solution, when fitting the metal bracket mount underneath the bottom shelf. Just fit in the R-hitched pin clips fastener, in the cutter hair pin, and you should be able to secure the wire rope lanyard cable. Like I said, this is just an alternative solution for demonstration purposes, but for the purpose of this video, we will be utilizing the steel wire as opposed to the wire rope lanyard cable. And in order to determine the installation location of the brackets on the wall, I first took the height of the wardrobe, okay, measured that against the wall, and then subsequently took the height of the wardrobe against the bottom shelf, the distance between the top shelf and the bottom shelf, or from the floor to the bottom shelf. Either approach is fine. Extrapolated or copied over this measurement onto the wall, and that's how I was able to determine the concise locations of the brackets on the wall. As long as the wall brackets and the bottom shelf brackets are facing each other, also ensure that the wall brackets are evenly distributed on a straight line, as your floor might be uneven or your measurements might be skewed due to parallax. So take the average and ensure that you install your brackets on a straight line, or you could use a spirit level. Once you're able to work out the first hole that your bracket would sit on the wall stud, you can just mark out the other hole from the bracket and drill through. And according to British Standard 7671, you're not allowed to drill 150mm or 6 inches from the return of the wall or from the corners and the ceiling. So you're not allowed to drill 150mm downwards from the top of the ceiling and not coving, as this is an electrical zone. The 150mm rule doesn't apply to your skirting where you've got the skirting applied, to the floor. And you should not be drilling vertically or horizontally from sockets or switches, or 150mm from corners. And it's better to drill through the center of your studs as opposed to the edges. And we can test this theory to see if studs are 16 to 24 inches apart, center to center. And here we've installed the plug right on the center of the three markings from the sensor. And when I measure from the center of one stud to the center of another stud, as you can see on the measuring tapes, it works out at 16 inches, okay? Roughly about 16 inches, okay? And if I spread out the center to center length to 24 inches, it should be able to pick up a stud, on the 24 inches location mark. And so the likelihood of finding a stud at the other end of the 24 inches mark is likely with the sensor. And if I zoom in to the other end of the 24-inch mark, you will see that, the sensor has highlighted that, I've likely got studs, behind the wall in them positions. And so the 16 24-inch center to center theory checks out, to a high nth degree. The next step would be to install, the plugs into the holes on the wall. So here, I have decided not to use the grey conventional plugs as they're not quite grippy and they tend to spin around in the hole. So I've used the Fisher Dual Power, which are quite sturdy and are more rigid. So make sure that the plugs are flushed against the wall. You can use a hammer or improvise using a pestle to get the plugs flush. As long as it gets the job done, it doesn't matter. And to illustrate that we haven't just randomly, drilled, random positions on the wall, I will get my sensor, impress it onto the wall, and you can see that every time I move it to the right or the left, three LED lights illuminates, which is, if you measure the three LED light points, it works out to be 1.5 inches, which tells me that, I've drilled through a stud, okay? But just double check with your Trueville multi-level pipe, cable, and metal detector to be sure that you're not drilling through metal. I've done my due diligence here, and I'm 100% confident that I haven't drilled through metal, water pipes, or live cables. And also remember that the drilled hole was anywhere between 6mm or 0.2 inch. And I haven't drilled beyond the tolerance limit of 1/4 inch, as the 6mm plug and screw is 0.1 of an inch shy of 1/4 inch in length. So the next step of the process would be to screw down the metal mount onto the wall. And so we will be utilizing a PZ2 screw bit, pop that into the chuck of the drill and, screw down the metal mount with the screws in their location holes. So here I am screwing down 4 metal mounts onto 4 studs respectively, and making sure they are screwed down flush against the mount and the plug in the wall. The next step would be to bound all mounts on the wall and on the wardrobe with a steel wire and a picture hanging wire. But prior to doing that, also check to see that the screws that you've driven into the D-rings and the 2 brackets behind the wardrobe aren't, protruding, from the center of the wood downwards, okay? If the screws caved out from the midsection of the wood shelf, you'd need to reinstall them. My steel wires are quite short, so I will be tightening at an awkward angle, so ensure that you get steel wires that are moderately lengthy. And also note that I have installed 2 extra back support brackets behind the wardrobe on the sides. So one mount bracket just on the right hand back edge of the wardrobe and the other just on the left hand back edge of the wardrobe. So the next action is to run the steel wire through both mounts and tighten, as exemplified here. My steel wire straps are quite short, I decided to fit, the brackets behind the wardrobe directly, as opposed to getting a hole here and, installing it, directly underneath the wood shelf. And so the wardrobe's width or breadth, which is 97.5, will be sat on that position and will end on this position on the wall, which is the distance from here to here. And if you take away the width of the wardrobe at 97.5 centimeter from both corners of the wall at a length of 260 centimeter, it leaves you an offset of about 81 centimeter, which essentially means that your wardrobe is centralized, on the wall. Prep the area, clean up the pencil marks with sugar soap, a cloth and some water. You actually don't need to mark on your wall with a pencil. You can actually do your markings on the masking tape, okay? And here, in order to tighten the steel wire, I have deployed the use of a plier. So I will use the pliers for balance to hold, the threaded end, and use my other hand to turn the cover, which is threaded on the inside. Pretty much turn it clockwise to tighten the steel wire together so that it forms a loop around both metal mounts on the wall and on the wardrobe. Then repeat and reproduce the process for the other three metal brackets each, both on the wall and on the wardrobe. And for more rigidness or sturdiness, run a hanging wire through the brackets on the farthest right and left of the wardrobe and the wall. And before you tighten the picture hanging wire on both ends, make sure you straighten it out so that it looks aesthetically pleasing. Click the description link to see how to use a picture hanging wire, and then straighten up the hanging wire for aesthetics. If you found the information useful, don't forget to subscribe, like and share. It does help the channel grow, and hopefully catch up with you later. Goodbye.